Okay, well, we'll make a start. Welcome, everybody. Thank you for joining us today at this the fifth webinar in our series for our 2025 series. If this is the first one you've joined, we're doing 2 webinars a month, which is one is more aimed at design professionals, and the other is a get together for tradespeople. Just a little bit about me. My name is Jessica Ayers. I am on the board of the Passive House Institute of New Zealand, and I also work as a passive house designer and certifier for sustainable engineering. For those people that don't know, PHINZ is a charitable organisation which exists to promote the passive house standard, but more broadly to promote good health and good well-being in buildings through good indoor air quality and energy efficiency, with a mission to reduce fuel poverty and to promote healthy buildings. Special welcome to our members. Thank you very much for your support. And if anyone is interested in becoming a member, then the information is on our website, passivehouse.nz. So just a little bit of housekeeping first. This webinar will be recorded, and there will be a chance for questions at the end. So if you do have questions along the way, if you could just pop them into the chat, and then we will read them out at the end. It really helps our speakers if you can have your camera on, but I understand that if you're multitasking, if you're working in your lunch break. So just to introduce this webinar, I first came across this project when it came across our desks as a certification project, and a few things stood out about it. The first is that passive house retrofits are extremely rare in New Zealand. Currently there is only one certified, and there's a good chance that this one could be the second. The other thing that stood out was that it was the incredibly low base that this building started at, and the incredible transformation that it went through. Another thing that is unusual about this project is that the architect, the client, the builder, and the passive house designer were all the same person. So this project is very much is a very significant project to Matteo and to his partner as well. I thought it was incredibly inspirational in its ambitious goals, and also impressive just with the evident effort that's gone into creating this warm and inviting family home. So just to briefly introduce Matteo Garbagnati, he is the director of collaborative projects, the Collaborative Project Studio, which is an architectural practice that he founded in Wairoa in Hawke's Bay. As you might be able to guess, he is originally from Italy, but he has been working the last 20 years in New Zealand and is a New Zealand Registered Architect. His focus is around sustainability, reuse, healthy environments, resource efficiency, and I'm very excited for you to see his presentation and for him to share this project with you. So Matteo, I will hand over to you now.
Thank you for the nice presentation, introduction. Yeah. Hello everyone. Sorry, never done this before. What shall I, can you see the slides? Are they shared?
Yes, we can see them.
Can see them. Oh yeah. So yes, Jessica introduced us, so that was kind of already starting what I'm about to say. That's us, the two of us, Gabriele and me. Yes, we are based in Hawke's Bay at the moment. We started, our journey in New Zealand, in Auckland. Then we moved here 5 or 6 years ago. So at the moment we are here, Wairoa, if you know where it is, but yeah, there is a slide showing where we are. That's what we do. we have done what we do, and we have done a series of community projects, public spaces, private as well. Private projects, I mean, residential, a bit of a range. We have done some work for the MRIs as well, mostly local, and some work, of course, also in Auckland. And about the presentation, so what I would like to go through is the first just an introduction about the EnerPHit standard, then talking about the project, general construction stages, and then more details about the actual EnerPHit design and construction, and then some briefly about material used, reused, and whatever else we've done, and then again touching on other external events and at the very end. So that's where we are, Wairoa, Hawke's Bay. That's a beautiful photo of Wairoa, and that's where the project is. So in this, pretty much in the town center, well, yeah, small town anyway. So town center, flat land, close proximity to the river. And regarding the standard, if some of you, I'm sure, are familiar already, but the certification that the Passive House Institute created are three families. There is the actual passive house, which is usually for new builds or retrofits. Then there is the EnerPHit, which is just for retrofits. And there are two methods for that. We'll touch on it as well. One is the component method, and one is the energy demand method, which is very similar to the passive house certification. And then there is the low energy building for where the requirements are a little bit lower, and that can be for buildings and retrofits. The EnerPHit component criteria, which is the one we followed, basically establishes minimum criteria for components, so like walls for the assemblies on the envelope, wall, roof, slabs or whatever else, and windows and doors, and so exterior openings. And then there is the requirement, the other system, the other system is the energy demand criteria, which, as you see in the warm zone, which that's where Wairoa requires to the heating demand has to be 15 kilowatt-hour per square meter per annum, which is exactly the same as for a passive house in this climate zone. The only difference is the pressurization test or air tightness requirement that can be up to 1 instead of 0.6. But anyway, we're not following this because we couldn't manage to achieve the 15 kilowatt hours per square meter per annum. And then, yeah, this is really, I approached it as a purely architectural presentation, really, with some details about the EnerPHit itself. So that's the building. Well, the site, a very standard, nothing outstanding, really. Slightly smaller than a quarter-acre section with a 1950 house on it and a small garage at the front. Yeah, some beautiful photos of it. There were even 2 fireplaces, well, one old one and one installed later. So obviously the owner didn't even bother to, well, whatever, upgrade the old one. And then here at the bottom, you see the front yard, the backyard. So yeah, quite spacious. The house has, obviously, well, we liked it because it has some interesting elements. Without specific order. So there was all the volume in the roof, as you have seen from the other photos. So the roof is quite pitchy, it's about 35 degrees. And the ceiling height was 2.4 standard. So immediately we thought, well, we should do something with that, or we could do. And then the other actually quite strong element were these floor-to-ceiling windows. Was a bit awkward that you could only open the top as a sort of an awning. But yeah, that was quite striking, and that was along the whole north facade. And then there was concrete floor, as you can see here, bottom right, through the worn-out carpet. And something we discovered later was the old roof under the pressed metal tiles used to be cedar shingles. So something that told us about, well, was kind of telling us that, you know, who built it kind of cared about the way it looked, but obviously they were quite budget conscious as well. Then, of course, as you start going through the work, the demolition, then you discover all these nice surprises, you know, wasps' nests in the wall cavities, asbestos ceiling, yeah, obviously borer everywhere, a bit of rot here and there. But yeah, that's just part of the game. And then the key objectives generally for the project that we wanted for us was to create a comfortable home for a family, say of 4, incorporating dedicated spaces for remote work, productive garden for homegrown food, design in general, no, design in harmony with existing structures and site conditions, enhancing rather than replacing, prioritizing resource conservation and optimization through the project, incorporate salvage materials into the construction process, and we have, well, yeah, you'll see, we have done some, integrate locally sourced materials to support sustainability and the regional economy. And yeah, we managed to do a bit of that. So you'll be familiar with this usual, how they call it, iron diagram, where, you know, you can't actually have all of them, but fast, cheap, and great, or with some different variations of it. So obviously, we wanted this project to be good design, summarizing great. But we had and we still have a very limited budget, so we are in the green overlapping zone. Plus, we also wanted to do a good quality, thermally efficient project. So that's why we chose for the EnerPHit certification. And yeah, it's a bit of an uncharted territory, but we're getting there. And so left, right, you see existing site, proposed site, in line with the initial points that I was saying before. We liked the building as it was, also because it was pretty much original. There were no strange additions, sometimes that you often see in buildings like lean-to and all this kind of stuff. And we liked it the way it was, especially the layout. We only added a new veranda on the well, that's west side pretty much, and then pretty much a new building on the front of the site, which is a workshop, office plus a carport. That's the bit at the top. Then we discovered, well, council had all documentation for this building, the historical documentation. This is the only drawing, so probably really that's all they had, and that's all it was actually produced. And this house was for Mrs. Davidson, and it was built by Mr. Davidson, so obviously it was same family. And I found this signature inside one of the walls. That's the original plan with the usual demolitions and new construction. You see that the layout is pretty much as it was. We've just done some fine refinement, small adjustment just to refine, and because the floor plan is quite compact, so small changes can make quite a big difference. But yeah, you'll see, I mean, the main difference will come later. So that's the proposed plan. Well, what's the new plan? 3-bedroom, 1 bathroom, nothing outstanding, and a laundry with a toilet and shower, and then kitchen, living, and dining all open. But obviously, because of all the roof volume, so we reclaimed all the space in the roof, and we managed to create a mezzanine, which is open to the downstairs living area, a plant room, another little mezzanine for 1 bedroom, and then a bit of storage space sections. That's the mezzanine. You can see at the top cross section. and long section, and cutting also through the plant room. That's a visual 3D, and that's, yeah, pretty much gives you an idea of what we managed to do. The floor height, it's yeah, as I was saying, the stud height at the floor, ground floor is 2.4, or was a strange number, but anyway, roughly 2.4. And at the top, we managed to, I think it's 2.3 maybe, from mezzanine to underside of the ridge. So, you know, quite compact, but definitely you can stand and you can, yeah, the mezzanine is definitely usable. Then construction phases broadly. So obviously demolition and the construction. Then we have done the asbestos removal. Then there was structural changes to the dwelling for opening up the roof and adding the mezzanine. And then there is a bit of photos about the outbuilding, which is not part of the certification, but yeah, it's important for what we're doing. And then the plan was to continue on the dwelling and finish it off. Yeah, you really probably can scroll through relatively quickly, but there was a garden shed. So going from top left, there used to be a garden shed, which was nothing special, but I managed to reclaim some weatherboards. There was native timber, which I managed to then reuse in the house. That was great for that. Then the shed was kind of rebuilt, so a new slab built over. Then the same time, we also started demolishing or deconstructing the house. We removed the chimney, we stripped off floors, we discovered all the several layers of vintage floor underneath. Asbestos removal, we got it done by specialists, and that was great. Not too expensive either. I think it was around $5,000. That was probably one of the few things that we got done by someone else. This one, obviously. And once they left, and once obviously I removed all the ceiling joists here and moved basically the ceiling joists higher up so I can start with the mezzanine. Then there was the first time you could actually experience all this nice volume and all the space, and you can see the underside of the cedar shingles as well. It looked a bit more like a church rather than a house. Then we started with the proper structural strengthening, or new foundations for the mezzanine roof, new roof structure. At the same time, we also rebuilt the shed, which was also quite handy because we could dry the timber that then we use in the house. Yeah, new drainage. This is pretty standard stuff. And then a bit of the more local flavors, material delivery. Obviously, Wairoa is probably not like, a big city, so you have to deal with, less smaller machinery, smaller of everything, and a very laid back approach. So the building supplier was more than happy to drive on the road with the forklift, not with the poles on, but yeah, with a forklift, yes. And then, yeah, continuing on our very low-tech approach, mezzanine beam, that's the mezzanine main beam. So obviously the installation was done with basic tools, straps here and ladder to support the beam on the other side and so on. Yeah. Then mezzanine is built, and we use the microcap joists, which are all locally sourced. I got them rough sewn, let them dry, machine them, install them. So everything takes a bit longer, but it's good. Then these slides are about the outbuilding at the front. Again, not part of the certification, but it's again part of the story. So that's the old garage, which we deconstructed the cladding, which we are gonna reuse in some areas, which is Remo cladding. All the rest is also dismantled and piled up. We might use it at some point. Then, yeah, just foundation preparation, all dug up, yeah, by hand with a shovel. again, low tech. And then we started doing, we've done the ground beams, footings. We've done some, well, I hired a digger because there was a portion of the fence which was also concrete blocks, which needed quite deep piles. So for that, the digger with the auger was very handy. And then these slides are about the slab. So the garage, although it's not certified and nothing like the house, we still, have done something sensible. So we have done insulation underneath and also outside the block wall because well, the block, it's block wall because on one side is right on the boundary, so it needs to be fire rated. Anyway, so yeah, I've laid the blocks. Again, another thing of Wairoa, so there are no block layers. Or if you want them, yeah, obviously they have to come from nearby city, Gizmo, probably. So at the end of the day, yeah, very hard to get them and very expensive, at least for us. So yeah, I laid the blocks. Then once that was done, all the rest was relatively straightforward. Again, another massive beam on the hip, which was, lifted with very basic tools, straps, and this kind of stuff, but it's all doable. Yeah, that's the external insulation on the garage block wall. We had it plastered by a specialist, and it was really good. And the bottom right, you see the garage, or well, this outbuilding partially cladded. That's all obviously reclaimed roofing, and I think is going to be the final cladding, obviously with some finishing trims and flashings. Well, the carport will come later, which will be an extension of this outbuilding. Obviously, we wanted the outbuilding to be built before continuing on the house because we need storage space. Then more delving into the actual house upgrades. So bullet points of the EnerPHit upgrades are pretty standard. Sorry. Pretty standard, nothing, outstanding, but yeah, basically they are insulating the walls they are all 90mm framing or thereabout. And we added a 50mm insulated service cavity. Usually, sometimes it's 90. Then insulate the existing and upgraded roof, new doors and windows, obviously, insulate the concrete floor, retrofitting the airtight membrane, and then mechanical ventilation. And then something not required for the certification is we also chose to have a CO2 heat pump hot water system that can also do space heating, and there is a bit more about that later. The way we started is quite, again, common. We just done the model with the energy model with SketchUp, Design, PEH, put all the inputs in, the geometries, shading. The veranda here is obviously a big component of the shading. We did a model, and Jessica pointed that out during the pre-certification process, that I didn't add the roofing of the veranda, which will add some shading. But yeah, that's again not perfect. It's all a bit of a learning process. Typical wall construction upgrades. There are two main types. One is with weatherboard, because the house has two claddings. Well, weatherboards, timber weatherboards, and the north facade was stucco. That was more, I don't know, facing the street. Maybe they like to have a bit more of representation, I don't know, representative facade for whatever reason. So obviously insulated the cavity, the 90mm framing cavity, and added the airtight membrane, which we used Proclima Intello. In some areas is plywood because of we use it for bracing, and then there is the service cavity with services. And the stucco facade is the same, except that we added an external cavity, drainage cavity, and new cladding. You will see more later. That's the process of upgrading the walls. Top left, we used drainage mat between studs and a wall underlay, which was retrofitted everywhere. At the end of the day, I had to replace 90% of the studs, one by one. And in some areas, I didn't even remove the weatherboards. I was just cutting the nails from inside, removing 2 studs and replacing them. Long process, but whatever, it's done. And what that allowed me was also to respace the studs, because some of them were a bit odd at 450, well, probably old spacing, 450, 600, 500. I respaced them all at 600 where I could, and obviously no nogging. Then the rest, I'm sure you're familiar with all this, nothing, it's all pretty traditional or whatever in this environment, at least. Insulation, we used a glass wall and then Proclime Intello, a time membrane. The other thing is the packing, so the bottom image in the middle. The walls were not plumb, obviously, so we had to pack pretty much all the horizontal battens, and varying between 0 and 25 mil. Bottom right, we integrated also, some feature lighting, making use of this service wall. So the wall is packed out a bit more. In this case, the service cavity is 90 mil, so we had room for a lighting feature. This is just a slide to show what we also have done in terms of services protection. There are these plates that you can just nail onto the studs, and obviously they prevent you from piercing services, pipes, or whatever else you have. And they're not easy to find in New Zealand, but I think they're very useful, and they should be made compulsory. That's the north facade I was saying, stucco, just during construction. The old facade, which was a bit cracky. But yeah, anyway, we strengthened it, we fixed it to the new start, so it was all kind of solid at the end. Retrofitting an underlay, putting cavity battens, which are just studs, 4x2s, treated, and then was insulated on the inside as the other walls. We also used the drainage mat on this side just to separate the insulation from the stucco. I didn't like the idea of the insulation touching that stucco, potentially having some condensation. I don't know. Roof construction upgrade, again, quite traditional for a certification type. 2 systems. The one on the left is with where we upgraded the rafters. So there are 150 rafters, and then there is the airtime membrane, and then 50 mil cavity, service cavity. And on the right, it's where we use the original structure. So it was about 100 mil rafters, airtime membrane, and then 100 mil service cavity. Overall, it's pretty much the same insulation, about 200 mil of insulation everywhere. Then some images about roof construction. Again, we used stripped off all the existing roof, the pressed metal tiles, the cedar shingles, and all the layers, underlay, battens, and purlins. Pretty. Sorry, I didn't say. It's a ventilated roof, so above sheeting ventilation, and that's why I was quite comfortable in making it into a skillion roof. Otherwise, I wouldn't have done it. It is just some flashing images I had. There was you can see that guy, a friend builder, very skilled and well, everything really. He gave me a hand with the roof, and he was really good with flashings. Yeah, vented. So it's a vented roof. Obviously, we have a vented drainage, vented channel, vented grill, cavity closer, how you call it, which was custom made, which was, yeah, it wasn't great, honestly, in terms of production. What was the building agency that produced it? And I think the reason is just is a perforated aluminum sheet, and it's obviously so much perforated that it doesn't hold its shape very nicely or very easily. And also manufacturing, I don't think it was very easy. So yeah, it'd be great if they can produce something a bit more reliable, because yeah, the width was not very consistent. Then what do we have here? Yeah, it's just some, more images about the roof. Yeah, that's what we were talking about, obviously. So once the roof was done, we started insulating. Again, glass wool, like glass fiber insulation. And then bottom right image is where the roof is lower. So, and that's the part that at the very end is just reclaimed as storage, and then forward is the little mezzanine for one of the bedrooms. Yeah, and then this retrofitting a new ridge beam, was also a bit of a mission. Obviously, I had to cut all the existing, so separate existing rafters from the old ridge board, shorten the rafters, and fitting in a new ridge beam, all while the rest of the roof was sort of propped and held together in some other way or form. But yeah, was good, I think. It's good to do it. You save space instead of putting it underneath or doing some other old stuff. Exterior openings. We used we have one skylight or roof window. We managed to use Velux, which is readily available. Overall, is a good product. I'm sure we are familiar with that. It's in terms of certification, we are pretty much on the edge on making it work, because you will see later the numbers. But yeah, even with triple glazing, it's very much on the edge. The image shows double, but we had triple. The installation is also quite critical, because it's all around the skylight on the outside. You see it's all packed with polystyrene, and also inside. One of the drawbacks, of course, of this kind of windows is you get probably too much unwanted solar gains, especially, of course, in summer. But yeah, other than that, it changes. I mean, from an architectural point of view, it just changes the space dramatically. So definitely a plus there. Installation, as I was saying, so all the blue region is all the packing of polystyrene that it needed to be done in order to make it work for the certification. But yeah, ultimately in terms of ensuring there was no, internal condensation or other awkward stuff happening. These are the images from Flixo. As you see, this bottom central image where it shows the FRSI, so the hygiene criteria, which is 0.559, and I think the minimum or maximum is 0.55. So we are pretty much on the edge. And Flixo also predicted that there could be some condensation exactly where the arrow is pointing. And believe it or not, I could find condensation there, right there, after it was installed, and I think it went through winter. So there was always some moisture in the room, in the house. And yeah, so Flixo, I found it was quite good, quite accurate. But yeah, the other thing about the skylight is obviously you see the installation speaks for itself. So the skylight is pretty much all sticking outside the thermal envelope, and you'll only rely on the actual frame of the skylight. That's your barrier between the separation between interior and exterior. So yeah, probably a different construction, different skylight would be, yeah, it's better. But yeah, that's what Velux produces. The other tricky thing with the skylight, at least with Velux, was to get accurate data for the glazing, the U value of the glazing. They honestly, the rep I was dealing with didn't even know what I was asking, but anyway. So at the end of the day, you have to calculate it yourself. So they give you the U value of the glazing at 90 degrees, so vertical. And then, as you know, as the glass in angle changes, the U value changes because of the convection inside the spacing, the air space. But anyway, we use this software, Windows and from Windows and Daylight, and yeah, you can just calculate it, so you can see 0.642 for 90 degrees, and obviously it gets worse and worse as it goes closer to the horizontal. That's just about detail about what you have to do in terms of certification. Exterior openings and windows and doors. We used these from Inwido or Elite Funster. They are imported by a company called My Kiwi Home. They are not a certified component like the skylight is not. That means also you have to basically demonstrate that, or well, calculate the U value of the assembly, which you can do it easily in Flixo, but otherwise, yeah, if you use a certified component, half job is already done. They are what we are using a timber frame with aluminum skin outside, triple glazed. They are, I mean, they are good windows. They're not extremely well performing. Obviously, they do a good job here. I don't know if they will work in a colder climate zone. That's something to test in PHPP. For us was we chose this because we came across them with another project where which was also going to be an EnerPHit project where sustainable engineering was doing the passive house design, and they recommended this. Well, they pointed out this window supplier, and so we tried it, and we got a quote which was the same price as a quote I got for timber windows and doors made in New Zealand, but double glazed, and I think was around 40,000. And for us was, well, if these are the same price, they perform better, and they have also the aluminum skin outside, so obviously no maintenance or much less maintenance. Then that's why we chose this. And we couldn't get, well, I tried, but we didn't manage to get other quotes from any other suppliers. Some they really just walked away as soon as, probably, I don't know, they thought we were joking because we were based in Wairoa. They might have thought, oh, these guys, maybe they can't even afford it. But anyway, a bit of disappointment there, but yeah, whatever. It is what it is. These are the extra from PHPP. As you see, they are all right performing, not amazingly performing. The U frame is between U of the frame is between 1.26 and 1.3, that's it. The glass, 0.88, which is fine as a triple glazing, not again top performance, but does the job. Installation, this was relatively straightforward, being timber framed. We added a packer of, again, rigid insulation shown in blue there, to lower the thermal bridge, or the installation thermal bridge, which at the end of the day wasn't probably strictly necessary, but I've done it anyway. And well, as you see, obviously they are well aligned with with the insulation. Floor construction upgrade. As I was saying, concrete floor, although it's about 60 to 70 mil concrete, unreinforced. It's more like a screed rather than a slab, really. And what we had done was to retrofit a damp-proof membrane on top because there was none. And we used an epoxy resin, and on top of that, we also use cementitious one. On top of that, there will be rigid insulation, 25 mil of XPS, and then engineer flooring right on top. Obviously, the constraints here are, you can imagine, headroom. You don't want to build up the floor too much, otherwise you lose headroom. And what else? Oh, well, there is also, well, I did play a bit with increasing the floor insulation, but then PHPP was showing that it would overheat more and more. Obviously, the floor has, contributes to also absorb some of the extra heat that the house accumulate. So at the end, yeah, we stopped. We settled with that thickness, 25 or 30 mil. Was kind of a good balance between not losing too much headroom, easy to install, and good balance between energy demand and overheating. Yeah, and that's the condition of the existing slab. Yeah, nothing great really. It was a bit scary sometimes. Quite thin and a bit damaged, but we managed, yeah, in order, well, to keep with the initial points. Now we just like the idea of, we keep we do the best to keep what's there at the moment, and we, unless it's extreme, well, unless you can't really work with that. That's why we kept it as it was. And this is just a quick comparison between the two types of insulation we could have used. So PIR or XPS. We chose XPS both for compressive compressive strength and cost. And here I have just two quick numbers. So the equivalent insulation to achieve the same R value or U value, XPS is about $16 a square meter, and PIR is almost double that. But the other thing is compressive strength of PIR is much lower than XPS, about 450 kPa for XPS and 100, 150, 175 for PIR, but it varies also with different brands. This shows the U value that we are achieving with that floor construction, and we could have achieved the same with a thinner PIR, but yeah, we didn't do it. Just as an example. Then, yeah, the other big thing is obviously retrofitting the airtight layer. The challenge was going through or going all around the existing ceiling joists where we didn't touch, where we kept them, and they were about 50 penetrations. I've cut all around the perimeter. I separated, yeah, cut short all the internal walls to create a gap that you see in these photos, about 50 mil, where I could fit this airtight membrane and easily without issues with taping or anything like that. But obviously the ceiling joists, I couldn't cut them. So just, sketching and thinking how it could be done, how it should be done. And at the end, yeah, the only way is just tape around it, really. In itself is, conceptually it's easy. Obviously, you're dealing with extremely tight spaces, especially you can imagine where at the end of or close to the corner of a roof, really you have to stretch and you work on you have to lay down on whatever, on the ceiling, in the ceiling space, and stretch your arms and work hope for the best. But yeah, at the end it kind of worked out. What I've done is also priming or painting the end of cleaning them as best as I could, then prime them with paint, so to make sure that there was no dust. And then once it was all dry, the tape was sticking pretty well to it. And then I just ran a strip of Intello from the top, cut it around the joist, drop a little bit underneath, and then joining the Intello with the one that was on the wall. Where we could, we have put the Intello before the ceiling joist, the floor joist. In this case, that's the mezzanine ceiling joist, and that's how you would do it for a new build. But obviously here we couldn't. Yeah, just standard services, sealing all the services penetrations, and yeah, the end result was good. I wasn't expecting that. So we had 0.45 air changes per hour. And ProClimber quite amazingly offered to do the blower door test at no charge, which was great. This is just the construction quality assurance pressure test. So we'll have to do one at the end for the actual certification. And then, yeah, just a fun thing. So that's the whole leakage area, that little square on the left, which is a bit smaller than a credit card. Then, yeah, the plant room. Great that, yeah, we managed to kind of create some space for it, because yeah, really, yeah, it's very useful. It's extremely cramped, but it works. We are using, as you recognize, steel electron heat recovery mechanical ventilation unit, and that's the one next to it is the EcoDan hot water storage. It's the split system CO2 hot water heat pump, and there is more about it later again. That's the typical arrangement for services, since we reclaimed all the roof space. Obviously, the portion where there is, yeah, roof meets ceiling or mezzanine floor, obviously you can't do anything other than running services. And in some areas are like that, now run there and then closed off, like shown on the top left. Yeah, that's the bottom right. You see how tight these mechanical ducts are. Space heating, the EcoDan split system can do also space heating, which was a good discovery for us. So we wanted to use a CO2 heat pump because of the low, or well, extremely low GWP, and obviously for the energy efficiency that a heat pump has. And space heating, so we arranged it with two radiators. One is a heated towel rail in the bathroom, and one is just a tall radiator vertical in the living area here, close to the table. And the overall heating load is about 1.2 kilowatts. With these radiators, you can calculate the heat output depending on according to the temperature of the flow and return water. EcoDan has flow, so incoming water is at 55 and return is 45. Well, I think you can also change them. You can even add them lower. But anyway, what this calculator tells you is how much is the output, and then so I just sized these radiators according to what we needed, and that's pretty much what it equals to in terms of standard electrical heaters. So not much, and I don't know how often we will need it, but whatever. It's seen. Then general PHPP metrics. The overall general heating demand is 27.4, so quite far from the 15 that you need for a passive house. Again, this using the EnerPHit component method, the heating demand doesn't matter. So it could be whatever, it could be 50 even. Because what matters is the component characteristics. As you see from top down, so the envelope it's relatively easy to achieve to stay well within the maximum allowed. So we get 0.21 as average U value of the envelope, and 0.5 on the right is the maximum. What's hard is, or harder, are the exterior openings, windows and doors. And despite we have triple glazed windows with timber framed, we are just, well, kind of just below the maximum that we can do, that we can use. Yeah, this is just showing general the balance, energy balance of from the PHPP heating page, heating sheet. Obviously the floor is kind of the weak point in a way, so that's where the most of the heat losses are. But yeah, it was overall yeah, we had to live with that, obviously being around retrofit. This was to show how the house was performing initially, like in its original state. So, you know, with single glazing, no insulation in the walls, insulation in the ceiling. PHPP estimated it, or yeah, estimated about 216 kilowatt hour per square meter per annum as a heating demand. And then after all this, we are down at 27.4. So it's about a 90% reduction, which gives the idea of the efficiency that you can obtain with this type of certification. And one thing that we noticed straight away, as soon as the insulation was in, well, this is quite recent, so pretty much all the insulation is in, the entire layer is in. You can see condensation on the outside. Well, you can see even the thermal bridges of the studs, and condensation on the outside of the glazing, which is quite common on a triple glazed window. Yeah, then this outside the EnerPHit certification part is more about materials we used. As I was saying, we use some macrocapa for, well, the mezzanine structure and the floor is all macrocapa locally sourced. You know, literally a guy that I met, he cuts down trees and mills them. Then you can go and get whatever you want, or you can cut whatever you need. Like this one, bottom in the middle, macrocapa beams. I literally just asked him this specific size, and we delivered it at home. And this would be the timber for the veranda structure, and the carport as well. So we like to use as much as we can of this locally sourced materials. And top right, that's the cladding, Remo cladding that came out of the old garage, which we're going to use for some interior linings. And then we also reclaim some framing timber from buildings that were demolished, being demolished here in Wairoa. Literally, you just go to site and ask for it, and in exchange for whatever, a bottle of wine or a box of beers, the usual. And we managed to, well, this is just one trailer load, but we had quite a few more. Most of the timber, so I first basically went through all the timber that we reclaimed for reframing or whatever we needed to do, and then only at the very end I had to buy some new timber for framing. Then what else? So the other reclaimed material, if you can say, or reused, are part of the garage, the existing garage at a block wall, which was pretty much useless. So demolished that and used it pretty standard as for the hard fill under the garage slab. And the old windows, which we didn't really want, we just sold them on TradeMe, for nothing, like $1 or $10, but someone else will use them. The same for the old PVC spouting. Yeah, somebody was definitely happy to buy and reuse them. And then, yeah, just jumping onto say other events because just checking time, so we are pretty good. Obviously, in a project you can do as much as you can do your best to control what you can control, budget, design, whatever, timing, but there are always external events that you can't control. And for instance, in Wairoa, you might know, heard, there was a big flooding in 2023, February 2023. While we were we were not affected directly, so our house was fine. The flooding was more on the north side of Wairoa. Obviously, it was major disruption for the town, for a lot of people that we know, and the district itself. So yeah, that was quite a important milestone there. Yeah, that's it. This image is taken a few days ago. So that's where we are at. Almost, well, lining is finished, so it's almost getting there.
Awesome. Thank you so much for that, Matteo. That's an incredible insight into the project, and you know, it's evident the amount of blood, sweat, and tears that's gone into that project. So congratulations. I find that it's just incredibly inspiring because you know, we know how to build energy efficient new buildings. But you know, we have some pretty established methodology for that, and a lot of experience with that in New Zealand. But the elephant in the room is the existing housing stock, and how we're going to upgrade that to you know, be as warm and healthy as we know that we can make new builds. So it's really encouraging to see that even with a project that had so many challenges, that you still managed to you know, achieve an incredible result. It gives me a lot of encouragement. So thank you. I can't see any questions in the chat. Am I looking in the right place, Nikki? Can you see any questions? I can't see any. If you do have any questions
at the moment.
No questions. Please put them in the chat. If you do have a question. I had some questions about the floor, because it might have occurred to some people that, you know, 20 to 30 mil of foam insulation is really not very much in you know, for those of us who are more familiar with high performance building, that doesn't seem like very much, but you were very limited with the space that you had and the floor construction that you had. Can you talk a little bit about you know, the passive house approach to that, and how, you know, how it's been sort of designed to be sort of flexible in this kind of situation where you're really limited with what you can do?
Oh yes, that's right. Yes, initially, since we started this project a couple of years ago, so we started with PHPP 9.6, so the previous version of PHPP, where the floor is assessed similarly to the other building envelope components. So I think it looks at the U value. So you have to stay with, we have to have a minimum U value, while and with that kind of criteria, we couldn't meet it, of course, because we only have limited insulation, and the U value is 0.86, and I think the requirement was maybe whatever 0.5, 0.4, I don't know. Obviously there was no way we could meet it. But then you remember also with we asked for an exemption, or we approached PHI, and we asking for an exemption, and they came back saying, well, upgrade to PHPP 10.6 because it looks at the envelope and including the floor in a different way. And so we've done it, and then without changing anything, it was fine, was satisfying the criteria, because it looks, the PHPP 10, you looks at the heat, what is it, the heat flow, the heat loss in a different way. And the other way, I think, with PHP 9.6, there was also that requirement that if you have limited space for NFE projects, if you have limited space or special overlaying characters, like if it's a heritage building, you have to use extremely high performance insulation. Well, the only option would be then PIR in that case. But yeah, you have to ask for an exemption. So, well, yeah, does it make sense?
Yeah, thank you. And just following on from that, how did it go with working around things like internal walls and bathroom fixtures? Like, how did you end up fitting the insulation around all of those fixtures?
Well, the services, they all run in the service cavity. So really there is not much encroachment there, and they were all new anyway. So all we had done is there was that slide showing the gap that we created between the external wall and internal walls. So I had to just remove the last stud that was attached to the external wall, cut top and bottom plate 50 mil, move the stud, and that created that kind of 50 mil gap just to separate the two walls, which was really so that I could run a continuous layer of Intello. And other than that, services, no, you're just making sure. Well, obviously there are a couple of penetrations through the envelope, they're all insulated and taped properly, or as best as we could. So.
And for instance, the bathroom fittings, did you remove those and then put down the new floor and then reinstate them, or put in new fixtures?
Oh yeah. Removed everything. Yeah, the floor, the house was all gutted. Yeah, so nothing was kept of the existing. And again, so yeah, I didn't say at the beginning, but initially, when we started renovating this house, we didn't have any idea of what we were exactly going to do. It took us maybe almost 2 years, really, to come up with this design. At the beginning, we were just kind of patching here and there and fixing a window there and fixing something else on the other side. But then little by little, we realized, well, this is not going to work, really. The windows, we realized afterwards that they needed to be replaced. So we said, well, okay, let's just do it properly. And that's when we chose to do the certification.
Yeah. Do it once and do it right.
Yeah.
Cool. So we do have some questions. So Damien says, what other skylight brands did you consider, if any?
There was another brand. I don't remember the name.
That's great that you managed to get the Velux to work. That's maybe encouraging for other people in your climate zone, that with only a little bit of tweaking to the installation, you managed to get the Velux to work.
Yes, yeah. So sorry, the question was which are the brands we considered?
Yes.
Yeah.
Yes.
So, well, I don't have too much experience with other brands because I never had to use them. I know there is Facro, which are really good, very good performing. I would assume they are better than Velux, but probably they cost much more. And I just stopped at Velux as soon as I knew it could work and I knew exactly the price. Yeah, I just stopped there. The price was a key thing, really. I think the skylight, which is the biggest with triple glazing, was something like $1,600, which I thought was really good value.
Wow, that's very reasonable. Very reasonable.
Yeah.
Magdalena says, did you have any issues with air tightness for ducting? Did it remain inside the airtight layer?
Yeah, all of them. Yeah, absolutely. Yeah. It's just a bit tight in the plant room itself, as you might have seen one photo where the one of the ducts that goes from the unit from the AHU to one of the distributor. It's very close to the Intello. Well, you know, it's within the airtight layer, absolutely, and within the thermal envelope, but yeah, it's tight.
Elron's got a comment here about the floor. He said he did a retrofit plan for a project in Auckland, and 20 mil of PIR over the existing slab was enough to achieve passive house. And Montaigne, he says, thanks so much for sharing such a great source of info. I have 2 questions. To retrofit the building paper, I can see you had a drainage mat against the existing cladding. Did you then tape to each stud, and was it difficult? It's the first question.
Nothing is difficult. Go do it. No, I don't know if I. What about what was the question about taping? So if I had to tape the wall underlay to the
Did you have to tape the paper to each stud, and was that difficult?
No, I've done it a bit in a bit of a maybe strange way, or maybe time-consuming way. I really squeeze the underlay, say I remove a couple of studs, no more, otherwise the weatherboard would fall. Remove the weatherboards, put the underlay as continuous as possible, put new studs, and then carry on. So the underlay is basically as you would do it from the outside with no interruptions or minimal. There are only a few points where I just couldn't do it. And then I ran a strip of underlay attached to the stud, put the stud in, and then maybe a few weeks later, I came back and put the underlay. And then in that case, yeah, I glued it. I used glue. Yeah, I used the Proclaimer glue to stick it to the old, or maybe tape. I don't remember, maybe both. And so just to create the connection between, you want that layer obviously to be as continuous as possible.
Yes, yes, and where you had the existing stucco, you had a drainage mat between the new building paper and the old stucco on the outside, which is a very good idea.
Yeah.
And then his second question is regarding the damp-proof membrane retrofitted above the slab. I understand there is no other options. Any concern on the slab durability?
Any concern? Well, I mean, obviously, it's not amazing. Well, you know, what can go wrong with that? Yeah, it could, I don't know, drop something heavy can drop from the mezzanine and it can make a hole in the floor. Yeah, that could happen. But yeah, not particular concerns really. Once it's all continues and reinstated, it's definitely harder than a timber floor, right? It's still concrete. It's not like super fragile, and it's overlaid, so no, not particular really. Well, I would have loved to have a proper slab, really, but
yes,
to deal with. Yeah.
Of course. So Jonathan says, how much did the retrofit cost?
Yeah, I think so. The numbers we have are roughly 200,000 for materials only, and I think it doesn't include GST. I just looked at all the reconciliation recently. I think it didn't. I looked at the column without GST. So say if it's plus GST, it will be 230, and that includes also the outbuilding. And roughly, I could say, I don't know, the outbuilding might have been 30 grand in materials only. So for the house, make it 170 plus GST so far. And I think we have another 10 or 20 to go. So hopefully, yeah, we can stay around the 200 mark for the house only. And that's all in materials.
Yeah.
Huh? But yeah, windows and doors are 40 grand itself, themselves.
It's a big component of it, isn't it? And you know, that's an amazing achievement, and it really reflects the amount of your own labor that you've put into this to make it really affordable.
Yeah. I mean, it was the only way for us, and yeah, otherwise you risk to overcapitalize very quickly.
Yes, but you do have the satisfaction of knowing that you did it all yourself as well.
Yeah, absolutely. Yeah. But yeah, with the downside that
Um,
it obviously takes long.
for sure, but you can't have it all always, as you
No,
pointed out. I
no.
like that slide. Simone says, amazing project, thank you for sharing. Now that it's almost done and with so much work, would you do it again?
Oh yeah, why not? Not on the same, not in the same house. Obviously, I don't want to do a bit of retrofit, but yeah. Give me some break, and I like to enjoy that the house a bit, because it's nice if you. At the moment, we live in again another old house, 1930 whatever cottage style. So obviously freezing in winter and hot in summer, and so uncomfortable. If you work on building site and you renovate your house and then you come back to a house which is nice, comfortable, it's nice. But if you come back to a house like this where it's colder than the building site, and it's a bit of a pain. But yeah, would be great. Yeah, if we have the cash to do it, yeah, I wouldn't
Yeah.
mind. I mean,
Well,
overall,
cool.
at the end, if we don't manage to enjoy the house, someone else will, and you know, that's again a bonus. Well, I mean, it would be good anyway.
Yes, and you've really respected all of the existing house and using local and reclaimed materials. It's an incredible achievement. Um, Luca says, how did the consent go? Did you have any challenges around that?
Building consent. No, I was
Mhm.
good. No, we kept it pretty basic, really. The main things that needed to be consented really were the structure and plumbing, drainage, obviously the outbuilding being all new. Honestly, the certification area, like the windows details, were not even included in the building consent. I didn't even, because you can't replace windows without
Mm.
consent. So
Yeah, yeah, a lot of it was exempt, I guess.
yeah,
Magdalena says, if you did have to do it again, what would you change? Would you change any details?
didn't think about it. Uh, Here, mm, maybe not. No, but don't know. I might have to think more about it. No, not really. Nothing
Oh,
that really strikes me at the moment. I mean, probably, yeah, thinking about it, I would the windows and doors that we chose. Yeah, I'm happy with that. It's a good price, I think, but I would have liked some another type with maybe more air seals. These ones only have one, and well, obviously it works, and they're great. They're awesome, really. They perform very well. But I know the out in the market that there are many types of windows and doors nowadays. You can have them here in New Zealand. So yeah, I would have spent maybe a bit more time and trying to be a bit more pushing, getting more quotes. So yeah, if you have the time to do that, yep, do it. Maybe we were a bit unlucky with the timing. It was just after COVID, I think. So maybe suppliers, I don't know, a bit
mm.
reluctant. Even we asked somebody in the South Island, I think it was Thermadura, and they said no, straight. Like no, we can't. We're not serving the North Island at the moment. So thanks.
Mm.
Mm.
Gosh. Were you able to quantify how much of the air leakage in the blower door test was as a result of the windows as opposed to the rest of the building envelope? Did you get a feel for that?
Um, yeah, I think there is definitely some leakage there, especially in the corners of a couple of doors where you can see there is a gap between the gaskets. I'll fill it up with something, with a piece of foam or something before the next blower door test. You can definitely feel the air coming through during the blower door test, and so that would definitely be one of the one of the area that I can improve. But yeah, other than that, no, I mean, if you install them correctly, they're good. So,
Well, overall, your result, your blower door test result was impressive. So they no, they can't have been too bad.
yeah, no, exactly. And after that, I even found couple of years where I forgot to tape properly. So there were a couple of gaps like this. So maybe we can improve.
Yeah, next time.
Yeah. Well, we have to do another one.
There's lots of really complimentary comments in the chat about how inspiring this is and how impressed people are. And yeah, for me, it's so inspiring. I'm looking at my potential retrofit through the window, and it makes me excited.
Yeah, great. That's
so
good to hear.
Yeah. Just a reminder that we have our Builder Social on the same subject with Matteo and also Terry Briers, who did the first EnerPHit project in New Zealand. That's coming up in a couple of weeks. I believe that's the 29th. So you're very welcome to join us for that as well, for a more informal discussion. And just a reminder that there are NZRAB points and also PHI points available for this webinar and for the next one as well. So thank you very, very much for your time, Matteo. I know this stuff is very time consuming, and I can see that you put a lot of effort into this, and yeah, we really, really appreciate it. And if anyone has any questions about retrofits, then maybe reach out to Nikki at PHINZ, and we can maybe pass the message on to Matteo. So I hope you all enjoy the rest of your day, and thank you very much for joining us.
Thank you.